this one, it's a blockchain certificate. And again, the reason why we're doing it is not because the goal is to make everybody a blockchain developer. It's to just understand what it is. People talk about this all the time. People talk about cryptocurrency. They talk about a whole bunch of other things. What exactly is that and how does it work? So there are two courses. The first one, the one that I just showed you, is a non-programming one. It's just theory. We're going to work on that today. The second one, the one that I sent in there, this one has a little more theory about something called Hyperledger, which is basically the idea of blockchain. We'll talk about that today. And the third one, which I recommend that you take and that you work on, it should take you about 3 or 4 hours to do. This one is in IoT blockchain for a supply chain. It goes through an actual example. You build it in Visual Studio. There's many, many steps to getting this done. We did the first little bit last year in this course, and I think about 10 students got the certificate at the end, and they finished up the course. There is a lot of new things that you have to learn. It really helps if you understand how programming works. So anybody who's like taken ANA 1001 should have no problem finishing this. Even though it's in a different language, it's all basically the same syntax, it's the same idea. It just looks a little bit different. So as long as you're okay with the syntax, the complicated part about this is that it teaches you a new IDE in Visual Studio. And it uses the IBM plugin to make it work, right, for Hyperledger. So let's go through, we'll take a look at the course, but we'll go through some of the high-level things about what we're talking about in the first place, and we're going to get started. So can somebody tell me, maybe we should start there, what is blockchain, or as IBM likes to call it, Hyperledger? Any ideas?
So blockchains are, if I simplify it, I mean, I don't have the exact idea, but they are a series of nodes, and each, you can say each computer or each system is one node. So in order to verify a transaction, a certain number of nodes must verify it for it to be considered legitimate.
I get it, but Daniel is right, and that's an excellent explanation for a computer science professor. Let's try again with the grandmother explanation. How do you tell your grandmother what blockchain is?
Well, I think that blockchain is a kind of decentralized system. So
great.
Whereby, yeah.
That's it. Daniel's grandmother's happy. You explained everything perfectly. She has no idea what a node is, but she knows decentralized whatever. It makes sense, right? The really important thing, the reason why I'm telling you this is because if you tell people what Daniel said, if they're interested in technology, they're going to say, oh, that's interesting. That's great. Tell me more. If they're your grandmother, they're just going to be like, I have no idea what words you're saying. I've never heard them before. Don't care. Right?
I think I might be stupider than a grandma because I still don't get it.
Okay. So basically, they're really, really simple. On your computer, you have a computer, I assume. You should, at least. You have two folders, right? Folder 1 and folder 2. And you copy a file back and forth and back and forth and back and forth. Make sense?
Mm-hmm.
That's it. That's the whole idea, right? So you can copy a folder as many times as you want, right? I imagine you have a credit card that you buy stuff in the store, right?
Okay.
How does it work when you buy a credit card, by the way? You go into a store, you swipe your credit card, and MasterCard or Visa has a huge network of all these computers connected to each other, just like the internet. It takes your credit card number, it routes it eventually to a bank or a database. It finds out if you have enough money. It goes back and tells the merchant, please authorize the card. And then it takes that same amount of money and it deducts it from your account or it charges it to you. Make sense?
Right.
All of that infrastructure is paid for by Visa and MasterCard. And the merchant pays Visa and MasterCard between 2 and 4% interchange fee to make that transaction possible. Right?
Okay. Yeah.
Okay, so cryptocurrency or blockchain or whatever is basically the idea that when you swipe your card in the same exact scenario, instead of Visa or MasterCard processing the transaction on a private network, other people are doing it. So for example, instead of Visa getting 4% of your transaction to make it happen, you're going to pay 2% to Krishna, you'll pay 2% to Purna, and they're going to take the data and push it across the network. Make sense?
Kind of.
So basically, it's like privatizing these big, complicated networks that are owned by places. I'll tell you another example, and this is closer to Hyperledger, the reason why we're talking about this today. There's a lot of stuff about cryptocurrency. We'll talk about that a little later, but it confuses this issue of ledgers, of duplication. Idris is an accountant, so he can tell you all about it. But I'll give you a simple example. I go into the store and I buy one banana. I pay $1, I get a banana, and the store gives me a receipt, right? Okay. The government says, I want to audit do a forensic audit and find out everything about this banana all the way until the farm. So what happens? They first get a copy of my receipt from the store. They get a copy of the receipt between the store and the supplier. They get a copy of the receipt from the supplier to the shipping company, a copy of the receipt from the shipping company to the farmer. And everybody has 2 receipts that go all the way back. So if we want to find out the origin story of one banana that comes from the other side of the world, there's a lot of receipts in between, right? Now let's think about something more complicated than a banana. Let's say like parts of an airplane. An airplane has 1 million different pieces. Those pieces have to be in supply in different airports all around the world. And sometimes between where they're manufactured and stored and flown to another place to fix an airplane, there could be hundreds of changes in custody receipts in between as the piece moves around. The same thing's true with diamonds. The same thing's true with any registered security like, bonds or stocks or diamonds or gold or other things. It makes it very complicated because if you're going and doing an audit to trace that item all the way back, At the same token, think about your bank. What is the bank? A big book, a ledger, and it tells you how much money you have. The bank has to create multiple copies of your account to make sure that it knows how much money you have, doesn't lose track. It also has to have multiple accounts of everybody's accounts, and it has to have all the transactions of how money moves back and forth between accounts, meaning it creates very complicated infrastructure. In other words, using technologies that you already know, like SQL, we could create a bank. We could make an account for everybody. We could make a file that says how much in a table everybody has. We can create files and tables for every transaction that happens. And that's the way it happens for most of the time. But what happens if something goes wrong? We have to create a backup of the entire ledger in another entire ledger. To expand that idea, imagine we started a bank, but instead of making all the transactions centralized, which would be really crazy to do, in fact, that's why Python, for example, uses batch transactions. It runs your whole code. It processes all 1 million people in a loop. It does all the things once in a batch, like a for loop grabs each piece and does something, right? That's because it's way more efficient to do what Python does in batches rather than use like real-time hyper-threading, whatever, to automatically do transactions. It doesn't make sense. Most processes in a bank are batch transactions because it's way cheaper. They don't run all the time. It reconciles your account every day. It sends out statements every month, not in real time. Make sense? So obviously some things do happen in real time, but you get the idea, right? So if you had a bank that had multiple branches, every branch would have its own data center, backup, server, and share records with the main branch. The main branch would do all these batch transactions plus keep track of its own records. And before you know it, you have like 70 records that are all the same. So instead, we have a system, and this is, again, the idea of cryptocurrency is that everybody knows the ledger is public. Everybody can see whose money is in whose accounts, but they don't know whose name is associated with which account. They could just see the big infrastructure of all the transactions going back and forth. In the bank context, the bank isn't interested in the privacy security part. They're really interested in the transaction part. So for example, going back to our banana, instead of the banana farmer giving the supplier a banana in exchange for a receipt and then keep on going forward, so we generate 10 receipts, we create one receipt. And that receipt, every time it changes hands for that 1 unit of banana, gets added onto. You can't change or erase those tokens. You can't, basically get rid of them. It's noted when they change hands. So if you wanted to audit the trail from you back to the farm, it would be that same one receipt that would have everybody's hands that it went through, making it far easier to trace. There's way less paperwork. Everybody gets a copy by default. And there's only one receipt that everybody shares and everybody can't change it. So everybody knows that it's good. You can keep on adding to it, but you can't erase it. It's like a mutual trust. Now, there are many, many different kinds of blockchains. Some are decentralized, some are centralized. It just depends. You might have also heard something about DAOs, which is like autonomous computerized company that makes decisions based on rewarding people for things. The unit of data that's moving across, in our case, like the receipt, is free, right? So for example, if I go to a store, I buy a banana for $1, they don't tell me, oh, would you like a receipt? That will be $1 extra. That's not the way it works. They might charge you for a plastic bag, but they don't charge you for receipts, right? That's not the way the system works. So that piece of information, the receipt that we're using, right, in a Hyperledger, they're all connected. They're all being shared back and forth. They're all free, basically. But depending on the way that we're using them and depending on the way that pieces across the network are moving, those contracts or items can have value also, right? So imagine I went to Idris and I'm like, hey, Idris, what do you have in your wallet? And he's like, oh, I have a receipt for a banana. I have a receipt for a can of tuna. And I'm like, this is a legit Idris can of tuna receipt. I'll buy it for $10. He's like, it's actually not worth anything. It's a piece of paper in my wallet. And I'm like, no, I want it. It becomes worth money because there's demand for it and there's a limited supply. There's only one of those in the whole world. He could go buy another can of tuna and get another receipt, and then that would generate a new secondary thing, but it's not the same as the first one. Each one's unique, right? And that's basically a super simplification of what cryptocurrency is. It's just basically these receipts that people are buying and selling for money, and they're worth a certain amount because people ascribe a certain value to them. There's no other economic reason besides supply and demand of why they're worth a certain amount. There are some other issues that are associated with them, like some are inflationary, some are non-inflationary. But basically, the thing that really powers them or fuels them is hype. There's no real economic basis for them. Now, we can debate whether or not cryptocurrency is a good idea or a terrible idea, whether it's actually worth something or not. I think it's really important to know that every time you hear in the news that cryptocurrency goes up by 1,000% or huge trades or people are becoming millionaires overnight, other people are losing millions of dollars because they took the wrong position, right? So it's not like everybody's making money all the time. That's a bubble. When the bubble bursts, there's massive crashes. So, before I worked at Cambrian, this is probably like 5 years ago, I was doing a lot of arbitrage and I was like buying and selling really rapidly in different markets using Python. And I said, okay, I'll do some cryptocurrency trading. And I spent like 3 weeks trading like nonstop, doing high volume trading using algorithms. And I made like, I don't know, $30,000 in a week, and I bought a new roof for my house. And I was very happy. I made $30,000 profit in a week. I was like, this is amazing. By the way, that same $30,000 that I was trading then is worth like $600,000 or $700,000 now. But you make these decisions when you make them. At the time, I was happy. I got a new roof. I didn't have to worry about it raining inside anymore. In retrospect, it would have been really good to hang on to it and see what happens and maybe pay for the roof a different way. I don't know. But that's life. Like, that's the way it works. You can't, But like I said, there is definitely a lot of hype that goes into it. But what I think is serious, the real underlying technology that's important to know about is the decentralization part, like Leader is saying. And the reason why it's so important is because right now, there's very few providers of big infrastructure, and they're mostly centralized. Even though they use cloud computing just means they're spreading your data across multiple computers, but there are physical computers somewhere that are running it. So when you watch Netflix, the movie that you're watching is a movie file that's physically sitting somewhere. And when you press play, it's coming from one of like 5 or 6 big vendors that control like most of the internet. So most of the internet sits in these 5 different companies' data centers. Things like AWS, Azure, and so on. So if you can use blockchain instead of the traditional way that we do things, you can change the way that databases work. You could change the way that data works inside the company, make it much, much easier to have financial transparency, but also records transparency to find out what happened to different files, where they went. Think about it like a system that everybody has access to and nobody could delete anything. Of course, in real life, if we were going to make a system like this, then only some people would have access to financial records, some people would have access to, personnel records, but the data itself, whether or not you could see it, is shared in many, many different places. and it creates an automatic backup, and it's moved between physical servers inside the company. So unlike a purely decentralized system like Bitcoin, which sits somewhere out there, well, the difference is that AWS, you pay to move files back and forth, right? Like, so for example, if you build an app on the web, like we take Martin's latest program that he made that he showed his grandmother, and he loads it onto AWS, and he says, new website, martin.com, click on my program over and over again, and 1 billion people click on it, his bill is going to go up like crazy, because the more it's utilized, the more expensive it's going to be, right? So blockchain is the same kind of idea, and there's many, cryptocurrency is the same kind of idea, except you're paying people a service to send you the data. So for example, I have the same program, same architecture, same idea. Every time somebody clicks it, instead of me paying AWS, you pay a little service fee to Vin. It could be called gas fees. It could be called something else, transaction fees, but basically you pay a little bit for that transaction. Just like when you're paying Visa and MasterCard to do it. Okay, hold on, Jyotish, that's a good question. We'll get to that in 1 second. Idris wants to know if it's open source, and it is. You could even type in Blockchain Explorer, and you could see every address, like every account on the blockchain, whatever one you're looking at. So for example, it could be Bitcoin, it could be Ethereum or something else. You could see everybody's wallet and how much money they have. You don't know whose names are associated with which ones. And often, if you don't use a public on-ramp or off-ramp, there's no way to know. It's just an anonymous account with money in it. Think about it like a bank, but every bank is a numbered account and nobody knows who anybody has. The only way to access it is through like a secret password, right? That's basically it. But once people start using it, then you can figure out who they are. So the other question is, what about storage space? So storage space in blockchains is not practical because, again, blockchains are very tiny contracts that just tell you what happened, where the data moved around. It doesn't describe or hold any data necessarily. There are decentralized storage systems that store large amounts of data. They store transaction data and so on. And those can be many different types. IBM is selling one that we're going to look at called Hyperledger, but there's many, many other kinds as well. So imagine combining this idea of smart contracts with a database that everything's decentralized, everything's stored in different places, and it's very low cost because you're only paying for what you need, but you also own the infrastructure, the architecture, right? So you only have to scale up your servers to run the system as you need capacity and demand. And you could even host these kinds of systems on AWS if you wanted, combining both ideas together. So there are a lot of different ways that this can look. I think there's a lot of bureaucratic resistance to people giving up control over their local databases. It doesn't make sense not to do it, right? To have access to records. I think just, it depends, right? Like Leader is saying, it's not a new idea. It's been around for a very long time. If you used something like LimeWire or Morpheus, if you're my age, back in the day to download music, or Napster or whatever, that's basically what we're talking about, right? It looks a little bit different. It uses different architecture, but that's the idea. You're downloading stuff from other people on this shared network. No, there's no security concerns because, the smart contracts that you're sharing back and forth are static files, they're flat files. They don't run code. They don't do anything. I don't think we've talked about Pickle yet this year, but Pickle is an example of a non-flat file that can cause security concerns in Python, which is probably the reason we haven't talked about it. So if you're using Pickle, I would be super cautious because you could easily make a virus that would impact other people's computers. So be careful with Pickle. But besides that, that's the idea. Okay, so basically the idea is that Python for trading, sure. So the idea is that, there's expert systems where we could look at building rules. If the stock goes above a certain price or below a certain price, then buy or sell, right? We could also look at patterns. If the price, goes up or down in a certain amount of time, then either buy or sell and so on. The problem is that if we build really complicated trading systems, Jyotish, nobody. That's the whole point. That the system or the people who are part of it, like Daniel was saying before, there's nodes that people host. They get copies of the data, and you're basically paying them to move around the data as you use it. So we started off where I was talking to Jess about moving a file back and forth on your computer. That's free. Doesn't cost any money. You're just using your own computer. But if you did the same thing on a blockchain, moving the file back and forth or changing it, you'd have to pay somebody to do it for you. Yes, there's a lot of different great courses. Too many questions. Hold on. There's a lot of great courses. I recommend some on Coursera that are very good. But as far as trading goes, you could also look at algorithmic trading, looking at how the numbers are changing in relation to each other, when to buy or sell. The big advantage of working with cryptocurrency as opposed to other kinds of things is that there's a lot of volatility, which means that the price changes a million times an hour very, very quickly, meaning that you could buy or sell much more rapidly if you build a system that does multi-threading. It's capable of checking a lot of prices very quickly, buying or selling, and putting in your trades very quickly, just because there's so many and the volume is so high. Also, the prices that you're working with for each unit are usually very, very small. So it means that you could own a ton of them and shift your position very quickly. Unlike in the stock market, if you buy too big a position, it might be very hard to get out of. You might lose money. So my biggest warning, and I'd like to tell this to all of you, I know that Purnell's already thinking about it. Look at what Dhruv just said right there. That's right. Purnell, read that. That is the most important thing that you're going to read today. More volatility means increased profit, but it also means very big losses. So I highly recommend, please triple underscore the very big losses part. You could lose a lot of money. Don't do anything stupid. That's my takeaway for today. Yeah, I know some of you are thinking about this. You really need to look at, like, if it's completely based on hype and it's like playing the lottery, and you could find a way to get around the market, so you're basically making better trades, and but a lot of things that are illegal in the stock market, like pumping and dumping strategies, you could do in cryptocurrency. And although some people have been prosecuted, most are not, because it could be anywhere in the world. It's anonymous, right? So you have to be very, very careful. So I would say really know what you're doing before you start building programs that do this. But maybe we could just take one more second before we get into this blockchain thing. I want to talk to you about something completely unrelated, but it involves all of you because you're students. So for a long time, I worked on software, I worked on trading that does something called arbitrage. Arbitrage means you buy something at a lower price and you sell it ideally right away at a much higher price in a different market. And it basically relies on the principle that all markets are trying to reach homeostasis, reach an equilibrium, that they're eventually going to be the same. People want to pay the same price across different markets. If you could buy something at a discount, you can sell it. Make sense? Okay, I'll tell you a couple examples that are really, really crazy. And they might not work anymore, so don't run out and do them. Research, obviously. So the first one is textbooks. So during the year, people buy textbooks for very little money. Normally, the only reason why you need a textbook is if you need them at university, which means people in North America buy textbooks in September, August, in January or December, and in April, May. Make sense? Okay. So what if I go during the year and I buy regular textbooks that are sent to me by the person directly? So you can go onto Amazon, you could buy a textbook for $5, and the person selling it to you does seller fulfilled. They'll mail you the textbook. If it's the day before class and you need the textbook right away, and class is starting tomorrow and you have no idea what's going on and you're worried about it, you'll pay extra money or use Amazon Prime to send you the book by Prime. Makes sense, right? If you had a choice, get the book in a month from now or get the book tomorrow, you'd pick the tomorrow option. So what people do is they buy thousands of textbooks. They just take off the sticker from the original seller and they just ship it back to Amazon. They're buying it from Amazon, sending it back to Amazon, sending it from seller fulfilled to Amazon fulfilled. And people make crazy money by reselling the textbook for a much higher price, but people will pay for it because of those times that people buy textbooks, right? The same item, they're just reselling them a different way. They did this so much that Amazon lost like $100 million on shipping costs because textbooks are very big and heavy. So they changed the metrics of how it worked to prevent that. But there are tons of software that does this. Let me find it for you. Okay, so there are many of these companies. In fact, there's some companies that will let you buy the books virtually and basically ship them back to Amazon in the same transaction, right? it will tell you, and if you look at the website that I just sent, it gives you an example that you could find the book used like new for $10 and you could resell it for $50, the same book, right? The only difference is this one's fulfilled by Amazon and this one's sent to you in 2 weeks. But if you're buying during the year, you're always going to buy the books early enough to do it. You'll find the book that you're able to leverage the price. And that's basically the idea. You find the book, you narrow it down, you look at the ranking of the books. Are people going to actually buy it? You find it at a cheaper price. Is it something that people want? And you can flip them. Of course, all of that takes a huge amount of time. It doesn't really make sense to do with one book. But if you build software that can go to Amazon and check for the difference of these books, even better, if you can connect to the Amazon API and download the data for all the sales information for that book, you could start to build an algorithm to tell you, is this a book that you should flip or not? Then you could expand that algorithm to 1 million books and then just buy all of them and send them back. And you get the idea of how quickly it can grow. There's also a website called, let me just find it. Camel. And Camel will tell you, I'll send you the link, will tell you the price of an item on Amazon for different markets. And it will tell you how the item's price changes over time. So we could look at charts, just like stock charts, but for every item that's sold on Amazon, and we'll get an idea of what has dropped the price, what's gone down, what's gone up, what's changed, and why, right? So for example, there's this MSI laptop, it went down by $200, right? So that's part number one, finding out what the price is on Amazon. Does that make sense? Yeah. Okay, so once you know that and you have that whole system working and you can do things like that, there's other software, and I'll send you some links so you could take a look. And again, you could build this software very easily yourself. This one is called Zen Arbitrage, and I'll send you this one, plus I'll send you a couple other ones. And the idea is that, let's say we did everything we just described. You did the book search, you found the item, and you say, okay, so now I know what the price is. I know what the information that I'm looking for is. Then you could start to do this process, which is looking at, okay, so I know what the sources are. I could start to cross-list all the items. So for example, you can create a Shopify store automatically, find all the items on Amazon that would have a lower price than Shopify, sell the item on Shopify, you fulfill the item on Amazon and send it by Amazon for free to the customer on Shopify, or connect Amazon to eBay, or even sell from Amazon to Amazon. So if somebody buys it from you, you're buying it from somebody else afterwards and shipping it to that person. You need to keep track of inventory levels, of prices, of price differences, of moving averages for each item. And you can definitely do that with software that goes through and batch updates every couple hours, checking if the items are still viable and how to sell them. I encountered many crazy situations where people bought a canoe, but they're on an island and the UPS driver is standing in the middle of nowhere in Quebec with a truck and a canoe calling me and asking me, how do I get to the island? I sold a gym full of exercise equipment to an exercise studio that was drop shipped from Amazon through Costco to whatever. It can be really crazy depending on what gets set up. But at one point I was selling over $10 million of stuff every month on eBay, or at least virtually listing items and then selling things from that. So basically you're picking like 10 or 20,000 items out of all the items sold on Amazon, which is like 45 or 50 million, to find which ones will sell for the right price on other markets. So I could be competitive with eBay, buy the item from Amazon and still make 10% profit or 5% profit or whatever it is. I did this for a while, so I made a bunch of money at it. But more importantly, I also made millions of air miles, and I flew to 40 countries for free by using air miles. There's a lot of side benefits. That's all I'm saying. So ultimately, the whole idea is looking at comparing APIs, checking the eBay API, checking the Amazon API, making them talk to each other. I would also point out that everything I just showed you, everything, the price for that software ranges from $100 a month to $1,000 a month for each customer that they have. If you could build software like that, you can make an incredible amount of money. And some of the software that we've already done, no, this is actually not something we teach in this program. But the point is that some of the software that you're developing is worth a lot of money. Like, again, I took a look at Sharon's site the other day. It works. It does something. It looks really nice. How much would a business pay for the same site to make it work? Can you maybe send a link to it so we can show people? Or like Vin's site. And for that matter, all of you in second semester are going to build fantastic looking sites. A business would obviously pay for that, even though you just use a template and plug some pieces in and made some variables work. I was approached by a company a couple of weeks ago. They wanted to do a sales calculator for something, right? If you can do that same kind of thing using an algorithm, then you already know something that's worth a lot of money to people, right? That helps them make money or save money, which is really the whole point, right? So I highly recommend it. Take a look at this website. It uses a bunch of stuff that we talked about in class, like the snow filter, just because maybe that's a seasonal filter. We'll only turn it on during the winter. And we have these different pieces. We can go to education, experience, BMI calculator. Each one of them uses a different endpoint. We could put in some information and make it work. This tells you the weather in Montreal is 258 Kelvin, which is obviously not very useful, but interesting. The thing that you have to know is that in order to make this work, which was kind of tricky, we had to change the CSS file. So the text that displays inside of a form is going to show up as black instead of as white. Otherwise, the text shows up as white. You can't see the numbers inside of the forms. But this works. You can put in your BMI, theoretically. And so I'm going to say 20 kilos, and I'm 200 centimeters high. And it says your body index is 5, and you're underweight. So it's going to figure that out in Python and then send out the results to the website. So we can do some pretty cool coding, which is really simple and ultimately worth money to somebody. That's the point. And I think this is a really nice example of that. And it shows you what you're able to do combining Python with Flask or other technologies that we're learning, right? But if you're interested in trading or you're interested in finance, there's a ton of courses. We're going to do some of them in BTA 1016. And definitely look at the courses on DataCamp of how to put those together. There's very good courses on algorithmic trading on Coursera. I recommend those as well. And LinkedIn has some really nice ones, algorithmic trading in Python. It helps to have some of the economic theory to understand like what's happening and how it works. And basically you're building a program that responds in real time to changing patterns. I'll tell you a terrible idea, at least I think so, you can disagree with me. I know someone who's in the process of building a stock trading sentiment analysis bot. So basically it takes Twitter data in real time. It looks at what's trending, who's talking about what, and what do they think, like what the sentiment is around those certain words. And based on that, makes trades in the stock market. Personally, I think it's a terrible idea because people often say something and do something else. And there's no way to predict what they're going to do based on what they're saying, but it is possible to do. Okay, so let's take a quick look at this course. So we're talking about blockchain. Again, there's 3 courses. I sent you the links for them. I highly recommend taking them, getting a certificate, showing people that you could do something that's different and cool. And it adds another skill onto your LinkedIn, and they're easy to do. It shouldn't take very long. This one, there's no coding at all. So to get started, all you do is sign up to the site. And I think I'm already signed up. If I'm not, Cognitive AI. And I believe I already have the certificate because I've done this course a few times. So it brings you into the course. It tells you learning objectives. You need to pass the course with an 80% to get the certificate. There's a quiz at the end. And it goes through and it talks about what are some of these things. It also gives you Enterprise Blockchain, which is a free ebook. Again, this course has nothing to do with cryptocurrency, and it talks about why it's different. Really, it's about a different kind of enterprise infrastructure. Instead of the company having like SQL with backups and so on, it just gives them a different way to use data. So it says business networks are often inefficient because each participant in the network has records or a ledger, and then they make 50 different copies of the same kind of information. One solution is a blockchain, which gives you shared ledger technology that allows any participant to see the one system of record or the ledger. So basically, it makes it a lot easier to share records across. They're all permanent. and it means that everybody has access to the one receipt, so they're all shared together. Make sense? So this gives you a whole bunch of different examples of how blockchain is used in business. And this is the quiz. And I think that's the entire module 1. Yeah, that was it. You should be able to go through that pretty quickly. And then let's take a look at module 2. So this one tells you some of their solutions and how it works and what the point is. Again, it's really helpful in complicated networks where there's like a million receipts that are being generated. This way you could have one central place to track them all. And then module 3 is basically showing you Hyperledger, how it works. You write an exam and then you get the certificate. You can put it on your LinkedIn. I really do recommend, if you want a challenge and you want to try something new, after you finish that course, which shouldn't take you more than like 20 minutes, go to the other course, which is this one. And this one's a little bit tougher. It's a little more complicated. Basically, to get started, you need to download Visual Studio Code, VS Code. And then inside of VS Code, there's a blockchain element that you add in, and then it will give you all the tools to build all the contracts. There's videos and they show you step-by-step how to do it, but it will take you a little bit longer. This is a new case study with an electron tracker. I actually have a whole bunch of these in my office if you're interested in how they work, although I haven't been to my office in 2 years, so it's hard to say, but I do have a whole bunch of those in my office. It's an IoT asset tracker, which gives you real-time communication with an IoT device. IoT is Internet of Things. So I recommend checking that one out for supply chain. And then this one, Blockchain Foundation Developer, is also a really good course. I would recommend do this one second. And this shows you Hyperledger Fabric. And I believe, yeah, this is coding one also. So do this one second. And this one goes through and shows you, let's see. So it explains to you how to install Visual Studio Code, how to install the IBM blockchain platform, how to get going, and then how to use like the VS Code interface to make it work. You might have this in some of your other courses, but then it will show you how it works. There's some quizzes, and that's basically it. So I recommend checking these out. It's a really good certificate to get. It gives you information to talk about something new with people, which really helps you like make conversation when you're applying for a job and things like that, right? It's also something that's very popular now. People are talking about Web3, they're talking about NFTs, they're talking about distributed network architecture. It's a good idea to know what they're talking about. Because in the background, we're analyzing data that's stored in different places. One of those places might be decentralized, right? And you want to know, is this a good idea or not? You might be asked about infrastructure by somebody. It's a good idea to know what the technology is, at least at a high level. Like I said, later on, we're going to work on the zombie course, and we're going to take a look at how those work. This is a course about developing Solana contracts, and we're actually going to go through and build smart contracts. You get a certificate for this as well, building for Ethereum network. The course is very fun. It's very easy to do. If you're in second semester, you should be able to just complete it, but we'll spend a whole session working on this and doing all the code. We could probably get through like at least a dozen modules in an hour, but we'll do that like after midterm break, just so everybody has the opportunity to be on the same page, because it involves more complicated data structures than some of the students in first semester know about now. So I just talked for an hour and 48 minutes straight, and I have a 2-hour class coming up with many of you. So I'll take a small break. Let me ask you a question. How is school going?
It's going good so far.
Going good. Good is good.
Yeah.
Learning new things.
That's good. That's the whole point. You know, I think that there's much easier courses to take. I'm always the first one to say, if you want a really easy course, there's many other ones. But this course actually teaches you real skills that you could apply in new ways, and you really learn things. Maria, I'm pretty sure that this assignment should take you no more than 3 hours. Yeah, Dhruv, I was telling you the other day, I do data camp every day. I don't know about you guys, but I do data camp every day. I log in, data camp every day. Because there's 3 million packages in Python. I got a lot of stuff to learn. And even the things that I know, every day I find new things. And I'm like, that's crazy. I had no idea you could even do that. Idris told me about a package I'd never seen before. And then we did that this week in class. So, you really got to keep on learning because there's unlimited things to learn. And there's so many new things. We're going to do, in this class, we're going to do machine learning and artificial intelligence. We'll do some machine learning examples and we'll build those in Python and incorporate them. We're going to do the machine learning for kids version some of you saw last semester, which is very easy to do, but we're going to build some programs that actually do really cool things. So listen, everybody is going to learn how to do everything, I think, or at least build the skills to learn how to learn. There's 3 million packages in Python. Once you learn how to use the first 10, it will give you the skills to learn everything else. And I have to say that I'm very impressed by the stuff that I've seen so far in both first and second semester, that people are really doing some amazing work, integrating what we're learning and building new examples and creating things that have a lot of value, And I think that everybody's going to see that this semester, whatever course you're taking, whatever semester you're in, you're definitely going to be able to apply what you're learning into new ways. So I want to remind you, this is very important. Get a tutor if you need one. The Tutoring Center has over 20 tutors that signed up. If you need a tutor in any subject, talk to Learning Center, they'll connect you. Definitely do data camp. I highly recommend log into data camp, work on the modules, whatever semester you're in, it's really going to help. And it really gives you that ability to start building the modules that you've done. Some of them are much easier than others. Some of them are way more complicated, but whatever ones you do will really help practice. The most important thing in coding, and for that matter, in all the courses that we're doing, is practice, right? Just practice, whether it's writing in English, whether it's working in code, whether it's looking things up. And the last thing I want to tell you, and this is probably the most important, I Google things 1,000 times a day. If you've ever met with me about anything, I don't know all of HTML, CSS, Python, or JavaScript in my head. I Google everything. And the only thing that I know how to do better than you maybe is what question to ask to find the right answer. That's it. And the only way to learn that comes from a lot of Googling. So don't feel bad. No developer in the world memorizes everything. It's not about memorization. It's about actually producing the end result. So please do me a favor and Google. If you don't know how to do something, look it up. That's it. Stack Overflow is full of millions of people like you with the exact same questions. Why don't you ask some questions too? Go onto Stack Overflow, say, how do you append a list to a dictionary if you're trying to do whatever? And if you can't find the answer, somebody will tell you, guaranteed. I get answers to my questions all the time. So please do me a favor, ask for help. It's not a big deal. It's expected. That's what you're supposed to do. I had a student that was incredibly frustrated that they can't get every single answer right the first time. That's not realistic. I never get the answer right the first time. I Google stuff constantly. But if you do that, you'll become a much, much better analyst. You'll be able to figure things out. You could ask people for help, right? 3 years ago, I sent you an email about the Cambrian Innovation Prize, right? Dhruv, you should definitely look at Coursera. They have a lot of really good courses on it. I did a very nice one in algorithmic trading that I liked. 3 years ago, we won the Innovation Challenge. This is the idea that the students had. It was a group of 4 students. They want to build an IoT device. Again, it's like theory. The IoT device plugs onto their shirt for somebody who's hard of hearing, and you have an earpiece. And as you walk around, it has image recognition. It sees a person, like for example, it recognizes Vin, and it goes, you're looking at Vin. Or there's a bus, or the sign is green. And it tells you that. So then it helps you, as you're walking around, describe the world. It uses a big database of images, machine learning, and so on. The reason why they won is because 2 reasons. The technical side, they wrote some code, and I gave them a camera and some software that does this. They wrote the code to make a basic MVP work, so they could show that their technology actually works. And they showed an example of it, which is very impressive. The other part is they came to me and they said, we need to build a business plan and a pitch deck. I do not know finance. I don't know marketing. That's not my area. I know other things. So I said, there's 1 million professors in the program. Go talk to them. They're happy to talk to you. That's their whole job. All they want to do is talk about marketing, accounting, finance. These are the people you need to talk to. They're the experts and they're right next door. They went to talked to all the different professors. They asked them to put together charts, slides, whatever. That's what they built their pitch deck on, 10 slides that show the business is viable. Not only did they win, I think they won $4,000 between the team, but there was an angel investor at the presentation that asked them if they would do the idea and give them $50,000 to be an early seed investor in their company. And this is for students in BAPG. You could do the same thing. You can win all of the contests that are available. There's 4 of them that are going on right now. There's the head competition. I met with a group this morning that's doing that project. There's the ones from the Canadian Evaluation Society. There's one from Innovation at Cambrian, and the other one's through TD. Sign up for them. You could definitely win. The ideas don't have to be complicated. They have to be a new and innovative, smart way to use technology, leverage it in different ways, find a solution, right? One of the people who won came up with a restaurant idea. We could do even better, right? So again, it's really about thinking, how could you apply what you know or what technology is out there in a new and creative way? Students last year said we could use OpenCV to look at video from a security camera, like for example, in a hallway, and find out where do people walk. Then we could find out what areas need to be cleaned the most. So we could send the maintenance people something so they could, eliminate COVID and germs from the areas that are the highest traffic. We could build traffic patterns of people moving around. This technology already exists. It's already used in airports. It's not used cheaply in schools with security cameras. It would make sense to leverage those technologies to find a new way to do something. Everybody in Canada is living in freezing cold, as many of you found out. And in the winter, the pipes in your basement could explode. And if they do, it floods your house and it's really terrible, right? So why not build an IoT sensor that costs $1 that you could sell for $30 that you put into your basement, or even better, you sell to the insurance companies and they send to all their insurance customers, saving the insurance companies from paying out $100,000 to fix your house for a $10 device. It's a built-in win-win solution. I made that up. You can take it if you want. You see my point. It's very easy to come up with an idea to build something that works. Talk to your friends, put together a pitch for any one of these contests. Some of them need a faculty advisor. I'm already taken with the head competition. So is Jenna, so is Guy. But there's many other faculty who are happy to work with you. I recommend approaching them and asking them to help you out, right? To be your mentor on the project to make it work. And I think you could definitely win. And each prize comes with a prize of thousands of dollars, which is good for everybody too. And it will definitely give you something that you can show to future employers about what you're able to put together. So talk to the people in your class. This is open for all students at all levels. And I'd like to take credit when you win. So please win, enter, make it happen. Exactly. You can do it. Maybe I won't take credit. I'll just tell people in the program did it. I told them to sign up. I don't know. Anyway, the point is, you could totally do it, right? Talk to the people in your class, come up with an idea, make it happen. And if you need help, you're free to contact me anytime. I'm happy to meet with you. Okay? So I hope this was interesting. Maybe we talked about some new things that you didn't know about before, or give you some direction to go in to do some new code. I highly recommend take a couple hours to do at least 2 of those courses. You can get through them very quickly, and it will give you some new LinkedIn badges. It will show some new skills that you have, and it will introduce VS Code. Yeah, so I highly recommend taking a look at those. And that's it. Any other questions, comments, thoughts on anything? No? Next week, Martin will be doing all the talking. So prepare yourself for that. It's going to be interesting. All right. I'll see you guys later. If you're in ANA 1001, I'll see you in half an hour. Otherwise, have a fantastic weekend. I hope everything goes fantastic. What's the modality for the bursary? The bursaries are over. The deadline was the 25th. So you can apply again next semester if you're still in school. But the way that it works with the bursaries is you fill out the first step number 1, which tells you fill out a questionnaire. Then you get step number 4, a faculty reference. Step number 2 shows you what you're eligible for. Step number 3, you include all the PDFs. And I hope many of you are going to win big prizes, right? Based on the stuff that I saw, a lot of people sent in a lot of things. Oh, when will they send them out? That I have no idea. That's a good question. I'm not sure. You could find out, email awards@cambriancollege.ca, and they'll tell you what the dates are. But I think they should be pretty soon. I'm not sure. Usually they have a dinner, and at the awards dinner, all the faculty serves all of the students. So, Thuck is very positive today. He says, maybe a month or never. So I'm hoping you're all in the 1 month or less and not the never, but if it's never, that's okay too. So I was serving meatballs with Jenna, meatballs, and students came up, my students, and they're like, "Hello, professor, I'd like some meatballs, please." I'm like, "Sure. What kind of meat? Like, excuse me, are these meatballs vegetarian?" I'm like, "I'm just like my only job is giving people meatballs. Stop harassing me. I'm just, I'm trying to do my job. They thought it was very funny. So unfortunately, I can't serve you meatballs. Maria, yes, there is a career fair next week. Highly recommended. Highly recommended. Go to the career fair. Go to all of them. And I'll tell you why. Number one, you may be the only person there, and if they have to hire somebody, they'll hire you. Number two, you can go to the career fair. It's online, it's on Zoom. There's a whole bunch of different CEOs that are coming, to HR people, to talk to people. Number two is Daniel does not want the job. He doesn't care. But it's an amazing experience to go through the interview process, to see what they ask, to answer their questions, to get an offer, and Daniel says, "No, thanks, I'm not interested." Obviously, it's a good idea to do that with a company you don't care about, and it's a terrible idea to do that with a fancy company that you really want a job with, right? Good practice. It's a good idea. I'm happy to go to the session with you. If you send me an invitation, what time it is, whatever, I'll go to the session. I'll be your wingman. I'll tell them how great you are. I could say lots of nice things about Krishna if you want. No problem. It's actually, there's a whole bunch of them. So there's like 20 sessions over 2 weeks. There's a ton of different ones. And again, I think all of you are fantastic. The only reason why employers don't think so is because they have no idea who you are. You have to make that connection and talk to them so they get introduced. I got an email from the head of recruitment at Cambrian, and she said, "How come there's no students? They're hiring a data analyst and there's nobody there." The CEO was talking to himself. So I went into there. I sent an email to all students in the program, and I'm like, "Show up to this meeting right now." And he hired one of the students who has a full-time job now, working as an analyst. Go to the meetings. It doesn't make any sense not to go. Worst case scenario, you learn some new people, you make some new contacts, and you could always email that person and say, like, "I'm graduating a year from now or 2 years from now. I don't know what I'm doing, or, I don't know who to talk to." Maybe they know people who can connect you to other people, right? Everybody knows everybody. It's a good idea to make those connections, build a network, or even say, like, "Can you spend 5 minutes telling me about careers in Canada? I'm interested in talking to you." One of the CEOs who came and hired a student was from India. He did his PhD in Canada, and then wasn't sure what he wanted to do. So he completely switched fields and he started to work for Microsoft. And then he started a software company. But basically, he knows a million people. He's connected to everybody at Microsoft. He's the right person to talk to if you want a job in Microsoft, right? You can only find that out if you went and go talk to him, like I did. So I highly recommend. You can invite me to the things if you want. I'm happy talking to strangers. You cannot invite me. That's okay too. But the point is, definitely go and talk to them. And we already went 2 minutes over. Anyway, I hope you have an amazing week and everything goes fantastic. Take it easy with the homework, and I'll see you next week. Bye-bye.
Bye-bye.
Thank you.